Hi guys, welcome back to another video. Today we'll be talking about derivative rules and what they mean and like how we can use them to calculate the derivative of simple functions like this one. So, firstly, when we take the derivative of a number, or like let's say like we're taking the derivative of x, right? X squared. What we do is the derivative is equal to the exponent. Let's call that n. So actually, let's actually erase that, and let's rename this to n. That's n, right? It's going to be equal to n times x to the power of n minus 1. So let me give you a simple example. Let's go back to x squared. X squared, right? The derivative of x squared would be equal to, we put the exponent on the front, 2x. We do n minus 1, so 2 minus 1, 2x to the power of 1, which is just 2x. So the derivative of this is equal to this. So let me erase all of this. Okay, so let's also learn how we can derive constants. So I know I'm going to be referring to this picture, this number right here, in this equation. So let's use the example of like 2. What's the derivative of 2? So 2 doesn't actually have a variable along with it. There's no x or anything. In a sense, you could say it's x to the power of 0, right? Because x to the power of 0 is just equal to 1. So 2 times 1 is obviously 1. So let's apply our rules to this. Let's see how I could phrase this. If we multiply 2 to 0 and do x minus 1, because we're subtracting 1 from 0, right? It'd just be 0 times 1 over x, which is equal to 0, right? That's just how it works. So that would mean that the derivative of a constant is just equal to 0. So now when we're adding numbers like this, like 2x plus 4, all we do is take the derivative of this plus the derivative of this. It's that simple. It's not the same for multiplication or division. That's where things like the product rule and quotient will come in, but we'll be releasing a video on those topics later. So let's take the derivative of this. So first off, what's the derivative of 2x? It's 2x to the power of 1, right? Multiply the 2 to the 1, that'll be 1 minus 1. 2 to the power of x is equal to 0. 2 times 1 equal to 2, right? And then derivative of 4, as we mentioned earlier, the derivative of any constant is just equal to 0. So that would mean that it's just equal to, let's name this function f of x. So f of x is equal to 2x plus 4. The derivative of f of x is equal to 2 plus 0 equal to 2. Which all that means is that the slope of any point, any tangent line at any point is equal to 2. And that's obvious, right? Because this is a linear function. The slope is always equal to 2, right? So now let's try to do it with a little bit of a harder question. Here we have a different question. We have a polynomial here, right? So it's not going to be easy to find the slope just by looking at the equation because it's a polynomial. And the slope changes at every single point on the graph. So let's start off by finding the derivative of 3x cubed. Multiply the exponent to the coefficient, 9. Subtract 1 from the exponent, 9x squared. All right? Now 4x squared, this one right here. Multiply the exponent to the coefficient, 8. Subtract 1 from the exponent, 8x. All right? Just 2 more. We have negative 5x, right? Negative 5x. Multiply the coefficient. So it's x to the power of 1, right? So multiply the coefficient to the exponent, negative 5. Subtract 1 from the exponent, negative 5, x to the power of 0, negative 5, right? Anything to the power of 0 is 1. And then obviously, constants have a derivative of 0. So for the final answer, we'll have 9x squared plus 8x minus 5. So assuming this is equal to f of x, right? So let's try to fit that in. This would be equal to f prime of x. So this little like apostrophe signifies derivative. Let's go on to our hardest example yet, this. So this is going to be a little bit difficult because now we're introducing fractions, right, and radicals, and even decimals, right? So let's start off. Let's use our basic knowledge. So what do we do? So it's just x to the power of 2/3 multiply the exponent through the coefficient. So the coefficient is obviously 1, right? So 2/3 x, subtract a 1 from the exponent, minus 1. So 2/3 minus 1 is what? Is equal to negative 1/3, right, guys? So that would mean that it would be 2/3 x to the power of negative 1/3. And if you want to simplify that even more, we could just do 2/3 over the cube root of x, right? So when we take anything to like a fraction exponent, the denominator of the fraction is what the root is. So here it'd be cube root. Let's say, for example, it was like 4, right, or 5. So 1 over x to the power of 1/4 would be the 4th root, right? So let's get rid of that. So that's our first term. Now, the second term is a decimal, but it's actually, we can just rewrite it as negative 4x to the power of 1/2, right? So we can do the same thing that we did earlier. Multiply the exponent to the coefficient, negative 2, subtract 1 from the exponent, okay? And that'd be negative 2 to the power of x, negative 2 times x to the power of negative 1/2. That'd be equal to negative 2 over x to the power of x. Oh, did I do something wrong? Yes, I did. So we won't need this x over here, actually. So negative 2 over the root of x, because this x comes to the bottom, because it's a negative exponent. All right, now let's clear up this work right here to free some room. And lastly, we have 3x. So it's obviously 3x to the power of 1. Multiply the coefficient, subtract 1 from the exponent, 3. That's it. Let's get rid of all this. Once again, let's rewrite this as a function. It's equal to x to the power of 2/3 minus 4x 0.5 or 1/2 is equal to 3x or plus 3x. The f of x prime, the derivative, is equal to 2 over 3 with the cube root of x minus 2 all over root x plus 3. All right? That's the derivative of this function. And that'll be it for the basic derivative rules. Thank you for listening, and we'll teach you more about multiplying and dividing in a later video.